AI is really about. Let me introduce them to you. First of all, here you see Venetia Menzies. She is a senior data journalist at the Times and Sunday Times newspaper, specializing in visual storytelling. Last year, she completed a fellowship with the LSE's Journalism AI program, developing a prototype tool to detect propaganda-like narratives disseminated by state-run media. Actually, it's not only Venetia that took part in this program, but also Ademola and Alessandro. So I guess they will tell us more about it. It's very interesting. Ademola Bello is an editor on the Newsroom development and support team at the New York Times. His work includes the training, development, and transformation of the Newsroom through collaboration with product teams. And prior to joining the New York Times, he worked as a data journalist at the Sunday Times and at the Times. And he was also a data scientist for the UK Civil Service. After that, we have Alessandro Alviani, the product lead for natural language processing at Ippen Digital in Germany. He leads a team dedicated to developing and building generative AI editorial tools. He's also a fellow of the Journalism AI Fellowship Program as Venetia and Ademola. And before joining Ippen, he worked as the editorial coordinator at the Microsoft News Hub in Berlin. And also he worked 7 years as the German correspondent of the Italian newspaper La Stampa. And last but not least, Christopher Brennan, a former journalist working for the BBC, France 24, New York Daily News, and the Moscow Times. And these days he moved from covering tech to creating it with Overtone. He oversees the development of language models that create qualitative data on news, as well as the creation of products so that data can be used by newsrooms and those who analyze the news. So you see we have quite impressive speakers here, and I'm very glad to give the mic to Venetia, who will be the first one to speak in front of you. And each of our speakers will have around 5 minutes to present its topic. They will be quite different from each other, so listen carefully. After that, we're going to have a short discussion here, and then you will get the chance to ask questions. Venetia.
Hello, everybody. I'm Venetia. Hopefully, I've got some slides coming. I'm going to talk to you a little bit about disinformation and also verification, so how we can find out what is true and what is false. So AI is going to have a huge impact on the information sphere that we already live in. I wanted to start by just explaining what disinformation is. It's actually different to misinformation. Disinformation is fake information, false information that's intentionally trying to deceive you, to manipulate you, to change your thoughts and to change your behavior. Whereas misinformation is more accidental, you could say. So AI is obviously going to make disinformation larger, more troublesome, but also has given us some methods to verify what is fake and what is real. So the first way in which generative AI specifically is going to worsen disinformation is in the quantity of it. And I apologize in advance, I'm a little bit of the doomster on this panel. So the first way it's going to do that is just increasing the quantity. It's massively going to increase the scale at which disinformation is made. A few years ago, you might have people in a bot farm or a troll farm trying to make as many comments and posts and images as possible. Now this can be done at a much larger scale. It can also be trialed better, so they could assess this narrative that we've put out isn't getting much engagement, nobody's really sharing it, but this other narrative is doing really well. Let's put all our efforts into that. I mean, we've seen this in the most recent conflict in the Middle East with Gaza and Israel. The amount of disinformation is massive. It's really hard to figure out what is real, what is fake, and it's been a real challenge for journalists to assess that. It's also going to increase the scale at which that content can be shared. By creating more and more websites, more and more users that can share that content. And so the quantity is a very big issue. The other way is obviously the quality of disinformation is going to improve. With generative AI, you could ask it to create disinformation that uses credible language, the sort of language that we rely on to know, as one of the speakers was mentioning before, the way in which AFP, Reuters will speak. If content is written in this way, we're going to be more likely to believe it. It can also co-opt more credible designs, glossy explainer videos, even co-opting the designs of professional media organizations such as the BBC. to try and trick us into believing in it. And I should say that disinformation is only effective if you don't know it's false. So the more we are able to identify something as false, it takes away that power of disinformation. However, generative AI makes that harder, let's be honest. So you can see here, this is a fake BBC tweet that says Joe Biden is going to resign from his post. It wouldn't be very hard to figure out that this is fake. You could just go on BBC's actual Twitter page, see if this tweet was shared, but how many people are going to do that? How many people are going to spend their time checking every single news source, everything they consume? Even the best of us can't do that. And even those who do, it's a distraction, right? So think about all the time that journalists now have to spend debunking narratives when that's taking away from the time that they could spend exposing something else. Yeah, all of this makes it harder to verify. I should mention here that this is where AI-generated images come in. This is where deep fakes come in. All of this stuff is now so much easier to make. It's so much cheaper, if not free, to make. And deep fakes specifically are a huge risk, because if we can't trust what our politicians are saying in a video, who can we trust? And even polluting the information space that we live in has already had a huge impact on us as readers and as journalists, because it's very hard to know what to believe. And in that case, even the truth, you become skeptical of. The other risk is personalization of disinformation. This is something that's already happening, but generative AI, in the two ways I mentioned earlier, by improving the quantity and the quality, is going to make this worse. So what do I mean by personalization of disinformation? If I want to change your mind, if I want to change your behavior, it's good for me to know what makes you passionate, what are you interested in, and how can I manipulate you? So firstly, to do that, I need to find out who you are, where do you live, how old are you, what are you interested in. This is quite easy. From data mining, there's a lot of our information already out there. And then I'm going to make tailored content that's specifically trying to change your mind. And as I said before, this is not a new threat, but the scale and the quality in which it's going to be done is going to be worsened by generative AI. I can give you some examples of this. Say you're a bad actor and you want to swing an election towards your favor. You know a specific demographic group is more likely to say vote for your opponent. How can you go after that group and try and manipulate them? So in the 2016 presidential election, there was actually a campaign of robots that called African-American voters in the US just on polling day and told them that the location that they had to vote had unexpectedly changed, which is attempting to take away their power, to disenfranchise them so that they don't vote. The African-American community was also targeted during the coronavirus pandemic by creating tailored content that took historical truths, for example, that they used to be experimented on in different medical procedures, to make people distrust getting the vaccine. So this is very effective, and this is going to get worse. The last one is misinformation. So as I said before, this is more kind of accidental. It's not necessarily trying to manipulate you, but it might. And the real way that this might be worsened with generative AI is just the inaccuracies that sometimes they will create. So if anyone's played around with ChatGPT, you know that it's not always perfect. I've got this example here. I don't know if you can see it, where I asked it, who's the most recent King of England? And it told me it was George VI, which obviously is not true because there's a current king. So yeah, it's not always correct. And if media companies start using it, it's really important that there's a human involved in that process to actually fact check things, because otherwise you're going to accidentally spread more fake news. Okay, so a little bit of optimism. A little bit of optimism. How can AI help us verify information? Well, there's lots of different tools that are developing that can help us. Probably the most common one that I use is reverse image searching. So, for example, in the recent conflict, there's been a lot of old images from Syria or old images from Gaza going around, which are not actually from this month, which are taken out of context and can deceive you. And reverse image searching will essentially allow you to see, has this image been used on the internet before? There's great tools that can help you do this. Google Lens, Yandex, there's a great plugin called Invid that will allow you to search all of the tools at the same time. And that will tell you, okay, no, this image didn't come out from Gaza this month because it was on the internet in 2012. So you know that that's not new and it's not true in the context that it's being presented. So that's a very useful tool that I use almost every day in my work. There's also bot detectors. So one thing that we learned, which we're going to talk a bit more about after in our prototype we made, was that there are really obvious patterns in terms of how disinformation is disseminated. So, you know, if you like something and you share it, the kind of organic engagement that would happen is very different from a bot. So if I'm putting out content and suddenly all of these accounts that are kind of linked to my interest are resharing this in a millisecond, it's very unlikely that that's organic. So it's easy to kind of identify bot networks, and that is useful to us. Also, there are tools such as Hugging Image, AI or not, that can help you detect whether or not an image is AI generated. Obviously, right now, you can maybe count the amount of fingers that somebody's got, and that might give you an idea of if it's a fake image, but I don't think we should be complacent. These tools are improving very quickly, so it might not always be so easy for us to spot an AI-generated image. So these tools are really helpful. They're not perfect, and there's kind of a technological arms race going on here where the disinformation is getting better and our tools need to get better faster. Yeah, there's also lots of tools that can help journalists investigate that my colleagues are going to talk about later. But yeah, I just wanted to explain a little bit about how Gen AI might make disinformation worse and how as journalists we need to be aware of that and need to keep on top of tools that can help us verify information. Thank you, guys.
Ademola, Bello.
I didn't have that in my one. That's really bad. I should have put my email address in mine as well.
Oh yeah. I forgot.
Slides will come up. So, hi, I'm Ademola Bello. Just waiting for my slides to come up. But you can call me Ade if you need to ask me any questions outside of the panel. I'm going to talk briefly about, because the title of this panel is Practical Uses of AI in the Newsroom. So I decided to just pick a practical example of me using machine learning specifically, which is a subset of AI, in an investigation that I conducted. Just waiting on those slides still. That's okay, okay. Just talk amongst yourselves, or ask me random questions, I don't know. Go for it. Great, thank you very much. Yeah, so like I said, I'm going to talk about the practical uses of AI in the newsroom, and I'm just going to illustrate it with just one specific example that I used while I was working at the Times and Sunday Times. And then I'm going to talk briefly about some examples that I have seen that are really good. So this is something I would classify under an example of using AI and machine learning in something I'd like to describe as news gathering, but also in visualizing the story. So the idea behind the story is that we were curious about bias in medical textbooks, specifically how the diversity of the imagery used in them informed how doctors are trained. So we had a very stark example of what you can see in that image there. It's this Kawasaki's disease. It's a disease that affects predominantly children and can be deadly if it's not caught properly. And one of the things that's very stark about it, and as you can see in that image, is how differently it appears on lighter skin compared to darker skin. So obviously, there's a variety of ways that journalists kind of report a story. So we had this hunch. We had spoken to some doctors, and we had some case studies of people who had experiences where their medical conditions weren't picked up because of the way it was reflected on their skin tone. So we thought, well, how can we find a way to kind of quantify this? Like, is there a problem in the textbooks that are used in the UK, and also in the resources provided to doctors in the UK. One such resource is the NHS website. So the NHS is the body that provides healthcare for the United Kingdom. And there's a website called NHS A to Z, and they basically provide like an A to Z of a bunch of conditions that like are more commonly, that commonly appear among people, and they sometimes provide images of those conditions. So we, essentially, the first question was to basically scrape all that information. So the images in these textbooks and the images on this website, and then could we classify and quantify what percentage of the images represented darker or lighter skin tones. So this is when we thought we could use machine learning and artificial intelligence. So we kind of, it's broken down into kind of like 3 basic steps. So if you think about an image is made up of tiny little squares, they're called pixels, and each pixel is a data point that represents like kind of the location and the color in that specific point in the image. So each pixel can tell you something about the color in the image. So there are robust methods already that exist in computer vision, which is like the field in computer science that's dedicated to understanding imagery and video, about like identifying skin pixels in images anyway. So we can find out, like we know there's a range of human skin tones, but we can kind of quantify that quite robustly, where we know what skin looks like, and we can isolate it in a computer with a computer. Where the AI and machine learning comes in is using this technique called clustering, specifically, I'm not gonna bore you with jargon, but specifically a technique called k-means clustering, which allows us essentially to take each pixel in the image and treat it like a specific data point. Once we have each pixel, we can cluster, which basically all that means is, as you can see in that second image there, allows us to segment the data points in the image and put them into separate clusters. These clusters will then represent the separate colors within the image. Once we have that, essentially, what that tells us is we can pull out the skin color in the image. So we have an image of a medical condition from a textbook that otherwise, manually, what you would have to do would be to kind of look at it and then using some sort of existing metric that we already have, try and identify if it's light or dark skin. But with this, we can use a computer to do this. And what this allows us to do, which I'll talk about a bit later on, is increase the scale, the number of images that we can analyze like this. Because we're talking about like using machine learning and in journalism, and it's kind of important to talk about the way these processes work. Once we do this, once we use this clustering algorithm to pull out the colors in the image, the human in the loop process, this final, the third image on this slide, indicates that there is always a person involved in that final step of choosing what color we think is represented in that image. So the algorithm will produce a bunch of clusters, a number of clusters. In this case, I've just kind of shown 2 of them. And then we, as individuals, will select that this is the image, this is the color in the image. Once we have that, what that tells us is that we have essentially the colors in these textbooks and in these websites. What that allows us to do is, actually, I'm going to take a step back. So once we have the colors, we now know essentially what every image we have in our data set, and this is a data set of over 1,000 images, what color is represented in that image. And then again, using, I don't want to bore people with jargon, but using kind of techniques to kind of the way in which colors are represented in the color space, which is like red, green, and blue. That's one way of representing colors, but there's also a way of representing colors that like looks at them via the way how light they are, meaning how close they are to pure white, as in like, which is on a scale of 0 to 100, which is on a scale of 0, which is black, to 100, which is white. What that allows us to do is put numbers to how light a color is on a scale from 0 to 100. So just going back to that first image that we had at the beginning, so this image of these 2 boys with this same disease, we can now plot on a graph where those 2 colors lie on a scale. And what that allows us to do is essentially quantify what proportion of images are light and what proportion of images are dark, essentially. And then that allows us to answer the question about the textbooks that doctors are using, how diverse are they, and what, how representative are they, and what does that mean for their practices as doctors. And in the end of that process, we're able to create a visualization like this, and you can see kind of immediately, quite starkly, the scale going from 0 to 100, where the darker images are clustered in this small little bit at the beginning, and then we have this wide kind of array of images that represent the lighter skin tones. And what that means is kind of can prove to be deadly. So we had a few case studies in the story which indicated people who had kind of experiences with doctors who couldn't diagnose them because of their skin tone. And that was something that we were able to quantify kind of materially using a machine learning algorithm. So one of the things we can do, because we have these things as numbers now, is that we can find like the median point. So the median being like the halfway point between all these data points. And the median for the data set that we have of images was about 72, so which means half of the images that we looked at all had a likeness value above 72, so at that kind of far right side of the bee swarm plot that you can see on the screen there. So what does this mean? Basically, it just allowed us, it's kind of a way of allowing us to scale up the investigation. So this is not something that would have been impossible to do manually. You can just take 10 textbooks and a website and write down every single image in the book and then try and figure out and allocate what a likeness value to that image is. But this allowed us to complete the investigation a lot quicker. Obviously, there's a lot of other things that happen with investigations in newsrooms that means it might not go as quickly as you want it to. But this increases the scale at which we can work. It made it easier to approach the problem that seemed kind of initially quite hard to quantify, because when this was brought to us in the team, you think about it and you go like, well, how do we want to approach this? And if we have kind of these tools, like these clustering algorithms, then it allows us to kind of approach this problem in a different way using computer science techniques. It also allowed us to visualize the phenomenon properly. So that bee swarm plot that I just showed is kind of immediately kind of indicative of what the problem is. You can kind of see that distribution and why that seems to be a problem. So that's essentially what we used, an example of using machine learning in an investigation. It's something I worked on last year when I was at the Times. And then finally, I just want to touch on a different example that I think is really important. This is a story that came out in September, I think, 2023, so a couple of months back. And it's essentially an investigation by Lighthouse Reports, which are an investigative journalism outfit based in the Netherlands. And I think they basically they looked at the information that you could gather from the city of Rotterdam, which was using what the Data Justice Lab likes to call automated decision systems. So this is, the reason I'm bringing this up as an example is because it's very useful to understand, like in this context, we're talking about AI and how we use them in journalism, but there are governmental agencies, private companies that are already using AI and using them probably quicker and at a faster pace than we in the journalism industry are. So one of the really useful things about conferences like this is being able to understand how AI and machine learning and these tools are being used by other actors. So this investigation was looking into how the city of Rotterdam in the Netherlands was using an automated decision system to adjudicate whether someone was at a risk of committing fraud for welfare. And they combined just kind of hard-nosed investigative journalism, which was they did an FOI request that took them months, and they retrieved the model that they used, that the city of Rotterdam was using to build this algorithm. So the model was essentially deciding whether someone was at high risk of committing fraud when they were getting their welfare payments or not. And what the Lighthouse report found was that this model was like greatly biased against a variety of people. It was using categories like age, which is something that you cannot control, to decide that you are high risk of committing fraudulent actions with your welfare. Single mothers who were of a migrant background were at high risk, just purely because of those factors that, again, that they can't control. So I think one of the really important things about kind of understanding AI and AI literacy in journalism is understanding how these tools work, not just so that we can use them, but so we can understand the people using them and how we can challenge them and tell the truth about the things they're using them to do. Thank you.
Thank you, Ade. I hope we will get to hear more examples in the course of our discussion. And now, Christopher, it's your turn.
While I wait for my slides, Jinami Bulgako, и аз искам говорим нещо по-български. Благодаря за поканата. Много се радвам.
I speak a little Bulgarian, so I'll try it. Thank you for the invitation. I'm glad to be here. That's all.
A quick background about me before we get into the presentation. I'm Christopher. I'm originally from the US, but worked as a reporter all over the place, Russia, UK, US, before covering tech in Brussels, covering data privacy and things like that. And covering those issues was really the inspiration behind starting to build models for newsrooms. And the other thing I'll say is that if I can do it, so can everybody else. So this is something, when we look at large language models, the journalism community can do it and can do it ourselves. We don't need to just sort of take whatever is marketed to us. So at Overtone, we do qualitative data for news, and I'll explain a little bit about what that means for a newsroom and sort of the practical application. Go ahead, next slide. Lovely. Oh, so the question, and they talked earlier in the Economist keynote about reaching audiences, and that's really what we can do now. So using large language models to reach your audience in a smarter way than has been done traditionally on the internet with all the algorithms that give people news. So most of the way that people get articles, that our audience reads articles, is through recommender systems. The way that these recommenders work, things like clicks, shares, keywords, likes, all of which are fine and all of which are good, but they don't really tell you anything about the content. These sort of big platforms surfacing articles to your readers, they don't really care what's in the content. Now with large language models, you can use them for writing, you can also use them for reading, and reading in sort of a human understandable way, creating data that really gets at the experience of what someone is reading on this other screen miles away. So that's what Overtone does. Again, shares, keywords, clicks, just the tip of that iceberg. Now with large language models, we can get at that other 90%. What is this text actually doing? This is an example that we use all the time. So these articles from the BBC have the exact same keywords. iPhones, India, China. They were published within a couple of days of each other, are from the same outlet, and have almost exactly the same number of words. So to most algorithms, to most recommenders, these are the exact same article. But it's not true. When you look at the actual text, the one on the left, basically a press release from Apple, such and such number of iPhones are being made, Apple said in a statement, etc. And the one on the right is on-the-ground reporting from India about whether this is going to work for Apple and whether this is going to work for India. So if you do look at the actual text, you can see these are quite different articles, and they're going to do better in different places. One of them might do better in a newsletter, one of them might do better on social, one of them might do better on a homepage, and you can have a human read them, but also if you use models, you can do this for every article in a matter of seconds. Why does it matter? It matters because different audiences also have different reactions to different types of articles. They have different user needs. Hopefully we can talk about user needs during the Q&A. We did a study for an Irish paper, for example, and found that of the articles leading to a subscription, 66% were the more in-depth articles. So the thing that got people to pay and really have a relationship with this newspaper was when they were doing big investigations, and they now know that. What does it actually look like? It looks like different models reading the text and then creating data on that. So we talked about fine-tuning. You can take these language models and fine-tune them to give you exactly what you want. Say, tell me whether this is factual or opinionated or inspiring, which is something that we're working on. And so then you can have, the second that text exists, an understanding of what it is and where it's going to do best for you. This is an example of what we do. You can look at the type of articles that exist for a publisher. This is sort of the standard news pieces, the investigations, et cetera, and then see what works best. The other thing is, again, when meeting audiences, what we've done is we've allowed sort of other platforms to be in control of where those audiences are meeting us. So if you can understand what your audience wants, you can help serve them the article that makes sense. Just an example would be with the recent conflict in Israel, Gaza. There are some people who come to that and there's all these quick update stories. This happened, this happened. That's gonna be great for users who are following that every day, all of the time. But another user who's just coming to this for the first time may want more of an explainer piece, maybe something to sort of help them understand more. So really it is about meeting audience needs. And again, sort of who do you want to work with? I think in newsrooms, if I were running a newsroom, I would invest in what we call purple people. This is not rendering super well, but I view the newsroom as very split between red people, sort of the editors, the reporters, going out, doing the work, and the blue people trying to make a business. And increasingly, there's this group of purple people, sort of data people, and audience people, and engagement people, and the head of AI now. And they're responsible for making sure that what the reporters are doing is getting to the right place in the right time, and they're ultimately answering to the reader, who is the most important, because that's the human. What news is connecting humans to humans, and if we can use AI to do that, that's the name of the game. In that spirit of connecting humans to humans, I will also comment on my shirt, which is the picture from Lou Reed, American rock legend, Transformer album, as well as a diagram of a transformer model. And I think it speaks to the idea of what we're doing is creative, but we can use technology to help further those creative goals. Thank you.
Thank you, Christopher. And now, Alessandro Alviani.
AI fuels innovation, but your art drives the essence of journalism's future. What a great quote to start. Just in case you're wondering who's the author of this beautiful sentence, I have no idea. I just found it in the chocolate I grabbed during the break, but I couldn't agree more. Let's have a look at how we have been implementing generative AI at Ippen Digital. And just in case you're not familiar with Ippen Digital, we are one of Germany's leading media companies. We run more than 50 news portals, including BuzzFeed Germany. We have 250 online editors spread across 9 editorial offices. And when we started to develop a framework for deploying generative AI tools in our newsrooms, and by the way, we started way before ChatGPT was launched almost 1 year ago, we quickly realized that we really needed a very strict set of editorial guidelines. So this is the reason why back in March, we established 5 AI guidelines, and this is basically a living document. We have been updating this document. I won't go through every single principle. I will just focus on 2 aspects. The first one is transparency. Transparency has 2 components. An internal component means transparency towards our editors. We organize regularly workshops for our editors to explain to them what machine learning, AI, large language models are, how they work, why. It's basically AI literacy. Why? Because we want to empower them. We want to show them the strengths, but also the drawbacks, the limitations of those tools. And transparency towards our readers means that every single article or image that has been produced or edited using an AI model is basically labeled And we will have a look at that later, how this looks like. And the second principle is human in the loop, or editor in the loop. That means that everything that goes online and has been edited using a model, an AI model, is always verified by an editor. So the human component is and will continue to be crucial at every single stage. And let's have a look at some examples. I have just we have been experimenting and using those tools in production already, and I have just some examples with me. And this is the first one. We have been creating pictures using different text-to-image models, including Midjourney, DALL-E 3, Adobe Firefly, and so on. And we follow very strict editorial guidelines also in this case. The first one is we never ever produce photorealistic images. As you can see, they are all illustrations. The second one is we only use text-to-image models to illustrate topics for which we couldn't find any interesting picture and in the databases we use. And you can see it here in this example here on the top left. This is for a story on tiger parenting. And the third principle, here we are. This is a disclaimer that we publish on all images, right below the image and at the bottom of the article. And this reads like, this is basically what we show here is the name of the editor was created, the picture, the name of the model we used, in this case Midjourney, and additional information on the way we processed this information and why it's important. This is a real editor. This is our art director. And this is really important to us. It's crucial. It's transparency. So everyone knows here we used an AI model, and there's a real person behind this tools, and there's a real person who has generated and verified and controlled the results. The second example is a tool that we integrated right into our CMS, because we really wanted to lower the entry barrier for our editors, meaning they don't have to basically log in into a different tool, but they can create suggestions for headlines and leads straight into the CMS. And what they do is basically, and here again, there's no automation here. There's always a human decision behind those tools. Basically, there are 4 steps. The first one is you activate here the tool. Okay, there's no automatic suggestion. The second one, if you are not satisfied with the suggestions, you can click on refresh and you get additional suggestions. And then if you like one of the 3 headline suggestions or 3 lead suggestions, all that is required to you as an editor is a simple click on this green arrow to replace the original headline. And the fourth one, and most important, editors can manually edit those suggestions in the CMS. And this is basically what happens. So you never ever get a suggestion and publish it, but you always edit it manually. And this is basically a source of inspiration for leads and headlines, and we developed it together with our editors. We have been experimenting a lot with reversioning content, and this is an example in our apps. Basically, we give readers the option to select the best suited format for them. If they, let's assume they have just 1 minute to read a story, they can generate a bullet point summarization. If they have 3 minutes, they can generate a bit longer summary. And we have been experimenting also with reversioning in simplified language. We have been fine-tuning large language models on our own data. And we create in this way, let's say, task-specific LLMs, because we know that There isn't something like an LLM, a large language model, that works best for all possible journalistic tasks. And doing this, we also created a very structured prompt pipeline and prompt infrastructure. We were Germany's first media company employing a dedicated prompt editor, a prompt editing team. And we also developed advanced metrics to benchmark those LLMs on the tasks we use them for. We have been developing AI image body tool. It is basically a tool that gives editors suggestions on the best way to illustrate a story. It's basically a combination of LLMs and computer vision. And we have been implementing agent-based SEO processes, agents and agent frameworks such as LangChain or AutoGen are really relevant, important to us, and we're doing a lot of work on this. And last point, really important, Venetia has already mentioned it, is fact-checking, and happy in our fantastic presentation already mentioned the risk of hallucination, meaning of facts that are basically made up by those tools. And what we have been doing is implementing different approaches to cope with this challenge. The first one is basically we test retrieval augmented generation to make sure that we can reduce hallucination. There will be tomorrow a workshop on RAG. I'm very looking forward to that. It's basically you want to make sure that that you use a large language model only for language tasks and not for knowledge tasks. It's basically you use your own articles as the knowledge base for what you would like to produce, and not the outdated training data that come with a large language model. We use a cross-verification approach, meaning large language model number 2 double checks what large language model number 1 has produced, and at the end of the loop you have always an editor double checking everything. And we have been developing tools to support our editors when they double check those content. We highlight the pieces of information that editors need to double check, that need to pay special attention to when they double check those content that has been basically produced or edited using large language models. And that's it. Thank you.
Thank you, Alessandro. I would like to start with our discussion now. I prepared in the beginning a personal question for each one of you so that we can go into this discussion. Venetia, first of all, tell me, in how far is AI integrated in your daily work? And can you give me an example when you are personally misled by a machine-generated information?
As I said before, I'd say the most common tool that I use is reverse image searching. In terms of our newsroom, I'd say that we're actually quite far behind integrating AI tools into what we do. Maybe one advantage that smaller organizations have in other countries is that they can move faster, whereas big organizations like I work for move very slowly. There's not really that much integration going on a large scale. I personally, I would only really use it to debunk things. To try and think of an example that I have been taken in by. That's pretty difficult, actually. I think right now, a lot of them are not very sophisticated. So if you are skeptical of everything you consume and you look at it, it's kind of obvious, but I'm wary of that changing. I wasn't really fooled by it, because I'd already heard that it was fake. But I think if I didn't know it was fake, I could have been fooled by it. Recently, there was a fake audio recording in Britain of Keir Starmer, who's our opposition leader of the Labour Party. And what I think was smart is this audio recording was made to sound like it had been covertly recorded. So there was background noise, there was lots of stuff going on. It sounded really authentic. And in it, he's swearing at people, he's being really nasty, and he's basically being made to look like a bully. And I'd already heard about it. I listened to it. I knew it was fake. But I think if I'd just heard that and I'd seen that, oh, look, Keir Starmer's been exposed to be a bully, I totally could have fallen for it. Because they'd created it in a way, it's kind of almost like in scams, you know, social engineering. They're trying to find ways that will trick you into thinking something's authentic. And the way that they did that, making it kind of covert with all this noise, really fooled a lot of people and definitely could have fooled me.
Thank you. Ade, you gave us a very interesting presentation about this investigation, how machine learning helped you get to a solution. But tell me how expensive this is. And speaking about larger and smaller newsrooms, do you think that these machine models can be used only by larger newsrooms where resources are available? And is AI going to be a tool which is used only by the bigger, and the bigger getting bigger, and the smaller journalists getting smaller? How is technology going to fit into this debate that journalism is facing right now?
Yeah, thank you. That's a really good question. And I can give like my kind of blue sky optimistic answer, and then I also have like the realistic answer of what's actually playing out on the ground, which is kind of reflected in a report that was put out by Journalism AI, which is an organization based in the London School of Economics that focuses on journalism and AI. So the optimistic answer is like, one of the good things about these models and the proliferation of them is that like the barrier to entry is kind of lower, like with some interest and like the ability to search things on YouTube, you can quickly spin up like kind of ideas on how you run machine learning models, like the investigation that I talked about. I learned some of the stuff about what to do via just like Googling things, so learning how to use clustering algorithms and stuff like that. So, but then obviously there's, the context there is that I do have a background in some like technical expertise in this. But realistically, to kind of refer back to that report that I mentioned before, there is evidence that shows that like currently there is a vast disparity between the kind of larger newsrooms who have the ability to deploy multiple people with technical expertise to address investigations like these and the smaller ones. But there are ways to kind of address this. So a key way to address this is like just collaboration between newsrooms. So large newsrooms, like the New York Times, for example, collaborating with smaller papers and local outfits to do investigations and provide them with resources. So like seconding engineers to smaller newsrooms to help them do things when they have ideas that they want to run. But another key part of it is, I guess, it's just having like the literacy to ask the right questions as well. And I think that's something that is doable by smaller newsrooms. It's just being able to understand kind of what kind of questions you want to ask. And although you might not have the resources, just finding the right people who can help you kind of answer those questions.
Thank you. A personal question to you, Alessandro. You presented your work and it's great, but have you ever been a victim of your own work? What I mean, do you have personal tools that you can differentiate what is AI-generated content, AI-generated picture, when it's not labeled like you showed to us? I mean, are you as a professional good enough to know what is machine-generated content and what not?
I will differentiate on when we look at AI-generated text and AI-generated pictures. So for AI-generated text, OpenAI gave up on its own basically detecting tool, because it's something that it doesn't work. And it's quite a challenging situation, because those tools, there was a fantastic investigation from the Stanford University. They tend to label as AI-generated articles or text that are written, manually written by people who are not native speakers in English. So this is something you really don't want to. And so there is right now no real, it's a great challenge. There are a lot of startups working on that, but it is something that you cannot reliably label as AI-generated content when it comes to text. When it comes to images, is something different. We will see tomorrow. We have a very interesting workshop on that with VerAI. We have Bellingcat has reviewed a couple of days ago a tool, AI or not, that works pretty well on images with high-quality images. It's great, but this is not helping us when it comes to, for example, to low-quality images that are shared on social media. So still, we have an issue there. And a couple of days ago, Adobe was caught selling AI-generated pictures over Adobe stock. And the interesting part on this is that basically the pictures on Adobe stock are labeled as AI-generated, but if you buy them and you reuse them, you basically don't need to label them. So what happened here is that a bunch of smaller newsrooms have basically republished AI-generated pictures that originally were labeled as AI-generated, but since they didn't label them as AI-generated, they are out there, and they are photorealistic images. And I think this is just, unfortunately, the beginning.
Very interesting answer. Christopher, something to you. You were a journalist for long years. You worked for great big medias, and you decided to move to tech. First of all, if I decide to do so, what should I do? Should I go into IT, I don't know, education, or it's possible just to be interested enough? This is also, I think, a question that a lot of the journalists here would ask. And I would like to ask you a second thing, because you worked long years as a journalist in Moscow. How do you see AI being used in the propaganda war that is going on in Russia and Ukraine right now?
Two great questions. Just on moving into tech, I think with that purple people, again, in the middle of the organization, sometimes you call that the product group. And so one of the skills, I said this on a podcast the other day, there's skills from being a journalist that translate incredibly well into something like product. When you're saying, what's the purpose of this? What am I doing? And you say that for a text, you say, what is the point I want to get across? And you can do the same thing for a product. If you're sending out a new newsletter as the head of product for an organization, you say, what do I want to do with this newsletter? Who am I talking to? And I think that skill translates incredibly well. I know Alessandro and I are both part of the News Product Alliance. And you see a lot of people in that group who are working on new projects, and they talk to developers. They may not all necessarily code themselves. And a lot of them come from purely editorial backgrounds. So it is mostly a matter of interest. On Russia, so I worked in Russia in 2012 through 2014. One of the things I think is very interesting that happened there is the idea of just flooding the zone. And what we're seeing now with AI-generated content is just floods of content. So you need some way to sort through it all. You need some way to understand what all of this is. But we had seen that in Russia. I worked for the Moscow Times, and we published an article and just hundreds of comments and trolls and things like that. I felt very hipster in 2016 when everyone started caring about Russian trolls, because Moscow Times had Russian trolls back in 2012, 2013. And so for the current conflict, I think you're seeing a little bit of the same, whereas if we just produce enough, then some of it will reach the people we want it to reach. The current systems of recommendation, based on clicks and by share and on shares, that don't really care about the content. If you create enough content, some of it will go viral. Some of it will hit the people that you want it to reach. And so I think we're seeing that now as well.
Thank you. In this context, which is the information which is hardest to verify?
I guess the most convincing. I'd say also, this is maybe a bit off topic because it's not AI generated, but if you're trying to verify, say, where an image is taken and there's not many visual clues, so you can't really figure out where, you can't geolocate it very easily. If there's an image in a field, how am I supposed to know where this is? It could be anywhere. That can be very difficult. But I'd say deep fakes that are really effective maybe would be the hardest to debunk. And at the end of the day, even if you finally manage to prove that something isn't real, There's that classic phrase of a lie is halfway around the world before the truth has its trousers on. That's a real problem. So there's a big move to try and pre-bunk things, which essentially just means prove something is false before it's come out, which sounds a little bit confusing. But that's actually something that we wanted to help with when Ale and Ade and our colleague Simone, who's not here, worked on with Parrot. So basically what we tried to do was create an early detection system that would look at output from state-run media, classify what kind of narratives they are and how propagandistic they are, and using a language model to say what kind of clues are there in this text that it might be propaganda. Maybe it's got a lot of exaggerations, a lot of personal attacks, they're not very much credible language. That's going to increase the chance that this is trying to manipulate you in some way. And if we created a prototype, if anyone knows any billionaires who want to make it a big product, let me know. But it would be able to say early, okay, we're seeing a lot of articles coming from, say, Russia that are saying there's loads of bioweapon laboratories funded by the US and Ukraine, before it becomes an established narrative. And then a journalist could see that and go, okay, I'm gonna write an article about the truth of this matter so that maybe if this narrative gets out there, people are already aware that that's not true. But you need these kind of early detection tools to be able to do that, which is a real challenge.
I cross my fingers for you that you find funding for it. We have a broad audience here. I hope someone will probably help you. But you said that machines can help with state control media and detecting what's right and what's wrong. So I think, all agree on the fact that humans and media can be biased, but can machines be biased as well?
Yes, that's a really good question, and I think something that might be addressed a bit more in the panel on ethics that's going to come on after this one. But yeah, the answer is of course, because all these models are trained on data, and that data is collected in particular ways. It's organized in particular ways, and all of those things kind of bake in the biases that we already produce, and then are just then reproduced in these models to a second order degree, basically. The idea is that the phrase I like to think about is when we approach these models is do as I say, not as I do, because a lot of times the models are learning from the way, for example, GPT has been trained is basically like a lot of the information on the internet. A lot of the information baked into that is biased. These visual These really amazing visual models like Midjourney. There are stories that have already been written about, for example, if you put a prompt to ask Midjourney to return an image of a South Asian person or South Asian man, it will return a very specific stereotypical image of what it thinks a South Asian man is supposed to look like. So those are biases that are inherent. So the machine itself isn't the bias is not coming from the machine, it's coming from the data that it was trained on, but what that creates is an amplifying of that bias. And another thing that complicates this situation is this tendency that we all have to kind of defer to kind of machines in terms of an automation bias. So we tend to think, well, if a computer has returned it, it must be an objective truth about the world. So what that does is, if you have this system that's based on biased information and then producing biased outputs, and then our reception of it is to defer to that system, that output, and assume that it's correct, that creates a whole host of problems. So yeah, there is a lot of issues around bias with AI and machine learning.
And Alessandro, do you think the time will come when AI will produce better articles than journalists, especially when it comes to fact news?
I think we had a look at some examples of how generative AI has been used, and it's basically a supporting tool. And I think this way it works best. Just an example, a transcription tool. It's a great way to help editors save time when we talk about generative AI, sometimes we tend to associate it with article writing, but I think it has a way broader spectrum of possibilities that we have there, transcription, and basically it's always supporting. What AI will never ever do is basically do basically research, preparing. It can help you preparing an interview, but will never run an interview. Will never write a great editorial. It will never, okay, yeah, a very generic one, So I'm not really scared about the idea. Is it possible? Yes. Do we want it? No. Do readers want that? I don't think so. So I'm not really scared of an AI model writing better articles there than journalists. Cooperating with journalists as a buddy tool, that's definitely, I think, the way where we see also the biggest potential, also looking forward. Yeah.
Okay. Thank you. Unfortunately, we run out of time. So, Christopher, last question for you. I read in one of your interviews that you say the real value of large language models isn't in writing, but in reading. Can you explain us why?
Yeah, I wrote that in a piece for Sifted, which is covers tech in the UK. I think when we think about what AI can do for us, we need to think about what it can do that humans can't. So in that piece, I talk about writing a piece of content versus writing the piece of content. And writing a piece of content is easy. You can type some words on a board, boom, you have a piece of content. That's not very useful to people. So what you want to do is you want to create the sort of content or find the content you already have that is fulfilling a specific need, again, for your audience. And that's what these machines can do, and that they're very good at looking at language signals. So you can say, oh, this person wants this article written as a haiku or written in the style of a pirate. Really, really excellent at doing that, all of these models. And so reading something and then transforming into that is fine. But the other advantage, as I think Abby mentioned in her presentation, is this fuzzy JPEG of the internet. If it's one of the cool things about it is its data is huge amounts of the open web, meaning that it has seen data about most things. So if you fine-tune that to make it produce with that sort of understanding or not understanding, whatever you want to call it, with that broad scope, if you can fine-tune it to create the sort of outputs that you want, that means you can start creating the piece of content, or at least finding the piece of content, rather than just any old words.
Thank you, everybody. I didn't realize that we almost ate the time for questions, but I hope we still have some minutes, right? Okay. Go ahead.
Hi, my name is Pauliina Grym. I'm from Finland, from the Finnish National Broadcasting Company, proud alumni of the WPI, also from last year. I have a question as a journalist. As it is impossible to be completely objective, even though you try, there's always something that colors maybe your opinions or your sites, how you view on a subject. Do you think that AI tools could help us journalists to detect our own biases from our text or content?
I'll go first. I think most people on this panel probably have a question about that. And the answer is yes, absolutely. Again, that sort of reading content, people are already doing this. I know La Nación in Argentina used AI to analyze the types of people they were asking for sources and discovering that it was largely men, even though there are many women, professors, experts, et cetera, who could answer similar questions. And I think for people's own articles, I think it's a smart use of AI and using it to read and say, okay, what are we doing and what should we be doing?
Yeah, I think definitely kind of picking up on the project that we worked on for the 6 months fellowship that we did with journalism AI, like one of the aspects of that model was to understand like language techniques that people use when they're writing. This was specifically focused around propaganda, but what you could pass to this model is text that you've written yourself, just to figure out the same thing, like what kind of techniques am I using? These are things that like are automatic to us. We don't realize we're doing them, but if you pass that information to a model, it will illuminate to you something about what kind of techniques you're using and what kind of biases that you may have. But I think Christopher's example is really, really, really great because understanding where sources and what sources are being used is a really, really important, and it's a big way bias is brought into journalism.
Maybe just quickly add on that. You can already now use it as a brainstorming tool and basically use an LLM and ask an LLM to provide you with counter arguments to your own argumentation. But at the end of the day, you are the one who's writing the article, so you can ask an LLM to provide you with counter arguments to your one. The question is, do you then use those counter arguments for your own writing?
Is there one question over there? Sorry. Yeah.
I'm Pavlina Mikhailova. I'm an independent journalist. One question to Alessandro. What about copyrights of the images you create with the artificial intelligence?
I think this is a huge question. We have been, of course, before we started editing, producing content, we talk with our lawyers and try to understand what's the legal framework here. And unfortunately, the legal framework is, the situation is not very defined, let's say this way. So it's legally, there are a lot, I think we heard about that earlier today. There are already legal actions in the US, and of course, we have been closely following the debate on that, and we have been, of course, when it comes to, for example, to pick a model, we look at models that are proprietary models, so closed models, but increasingly also at open source models that you can use with a commercial license, and I see there huge potential for the future.
Well, thank you once again. So